Hi, welcome all for the last part of the video lecture on the topic support reactions. In the last three parts, we have discussed about the concept of equilibrium, and we have discussed about equations of equilibrium conditions, support reactions, types of supports, and what is beam and what is the use of it, what are the types of beams, and in that types, what are the classifications of the beams. So in this video, we are going to discuss about the last topic, classifications of loads. To design the civil engineering structural elements, we broadly classified the loads into three types. In that, first one is point load or concentrated load, and second one is uniformly distributed load. We can name it as UDL, and lastly, uniformly varying load. Also, we can call it as varyingly distributed load. UVL or VDL, both are same. Now I will move on to the first one, point load or concentrated load. The name itself indicates the load is acting on a single point. Observe this figure. Here a person is standing at a distance 1.5 meter from A and 4.5 meter from B. While designing this beam, we are considering that this person is applying load on a single point. Even he is having some contact area, we are neglecting that one. We are thinking that it is acting at a single point. So the 2D figure will be like this. Here it is a simply supported beam. VA and VB are the reactions due to the applied load. P will be the load. The unit for point load is kilonewton. Either it is kilonewton or Newton. That will be the unit for point load. The load is acting at a single point. Then I will move on to the next one, that is uniformly distributed load. Here also the name itself indicates load is distributed uniformly over the area. If I observe this figure, the people are standing on the slab. To design this slab, we need to consider this load as live load, but each person is having different weight. It is not possible to measure each one. So for designing purpose, we are assuming that all are having same weight. This is what we can call it as uniformly distributed. If it is a beam, here also same thing. All are having different weight, but we are thinking that for designing purpose, all are having same weight. So in the free body diagram, we can write the uniformly distributed load like this. Here it is distributed uniformly throughout the length of the beam. A and VB are the support reactions. L is the length of the beam, W is the intensity, and the unit of UDL is kilonewton per meter. We can write the same figure like this also. Here it is distributed uniformly. The intensity is W, unit is kilonewton per meter. To calculate VA and VB, we need to convert this UDL into point load. Then how to convert that one? It is very simple. To convert to point load, UDL intensity W kilonewton per meter spread over a length can be converted into an equivalent point load by multiplying the load intensity with the length W into L, which is acting at the middle of the length L by 2. Means, so we are having W is the intensity uh, and length is L. So if I multiply that W into L, we will get it as a point load. Kilonewton per meter is the unit of UDL. Length is in meter, meter will be cancelled. Now the point load unit is kilonewton. This is what the conversion, and it is always acting at the middle, means L by 2 and L by 2. Here also the same thing, W into L, which is acting at a distance L by 2, L by 2. Unit is kilonewton. Now I will move on to the third type of load. It is UVL or varyingly distributed load, VDL. So here also the same thing. The load is varying uniformly throughout the length. Here it starts from 0, it's having some weight, it is increasing uniformly, okay, and it is increased to some maximum value. So this type of distribution we can call it as uniformly varying load. If I draw the free body diagram of that, it is like this. It is a simply supported beam. In that beam, it is subjected to uniformly varying load. It starts from 0 and it is increasing uniformly, and it increases to the maximum intensity W. Here also the unit of UVL is same, kilonewton per meter, and the length of the beam is L. VA and VB are the support reaction. To calculate those support reactions, we need to convert UVL to point load only. The conversion is also very simple. UVL of intensity W kilonewton per meter spread over length can be converted into an equivalent point load by taking an area of triangle half into W into L, which is acting at a distance 1/3 of L from the maximum and 2/3 of L from 0. Means, so it will look like a triangle. We need to consider the intensity. The maximum intensity is W and the length is L. If I consider the area of the triangle is half into base into height, half into W is the height, and length is L only, half into W into L. Now the unit is kilonewton per meter and the length unit is meter. If it is multiplied, meter and meter will be cancelled. The final unit will be kilonewton. This is what the conversion of UVL to point load, and it is always acting at a distance 1/3 of L from the maximum intensity level and 2/3 of L from the zero intensity level, because the centroid of the triangle will always at this distance only, 1/3 of the L and 2/3 of the L. This is the reason it is acting at this point. So this is about types of loads.